Today, we learn how to use scale ratios to find drawing measurements when we know the actual measurements, and find the actual measurements when we know the drawing measurements. Where are scale ratios used in real life? Scale ratios are used when reading maps and when creating scale models. So we should remember scale ratios tell us the relationship between measurements in the drawing and the actual object. Scale ratios are written as the drawing length compared to the actual length. For example, scale of 1 centimeter to 4 meters means that 1 centimeter on the drawing represents 4 meters in real life. We'll now use scale ratios to find either the drawing measurement or the actual measurement. We'll follow these 3 steps at the bottom of our page. Note, if no units are given, we assume a centimeter to centimeter ratio. Also, depending on the question, it is often safer to perform all scaling conversions in the same unit, then convert to an appropriate unit at the end of your problem. Find the drawing measurement when the actual length is 20 centimeters and the scale ratio is 1 centimeter to 4 centimeters. Step 1, simplify the given ratio. It's already in simplified form. Step 2, align the ratios vertically. Step 3, we must scale up. So we have scaled up by 5. We multiply by 5 and we multiply by 5. So our final answer is 5 centimeters. Second example, find the actual measurement when the drawing length is 7 millimeters and the scale ratio is 2 millimeters to 10 millimeters. First, we simplify the given ratio and we divide both numbers by 2, so we have 1 to 5. Now we must place that 7 in the correct column. Step 3, we need to scale up. We are multiplying by 7. So we multiply the 5 by 7 and we get 35. And there's our answer, 35 millimeters. Third example, find the drawing measurement. The actual length is 15 meters and the scale ratio is 1 centimeter to 3 meters. Now in this question we must remember we want the same units. As we can see, we have our ratio with 1 centimeter to 3 meters. Let's first convert that. We have 1 to 300 because 300 centimeters is 3 meters. Now we place our 15 in the correct column, but it is 15 meters. So we must convert 15 meters into centimeters. We multiply by 100. We would simply just add another 2 zeros, 1,500 centimeters. We need to scale up or scale down. We have multiplied by 5. So we have to multiply by 5 on the left. 1 multiplied by 5 is 5. And there we have our final answer, 5 centimeters. Example 4, find the actual measurement when the drawing length is 3.5 centimeters and the scale ratio is 1 centimeter to 4 meters. We're going to convert the 4 meters into centimeters. We multiply by 100, so we have 1 is to 400. They tell us the drawing length is 3.5, so under the 1 we have 3.5. Step 3, we have scaled up by 3.5, so we must multiply the 400 by 3.5, 1,400. Now that is 1,400 centimeters. Let's convert that back into meters, so we divide by 100, and when we divide by 100 we take away 2 zeros and we get 14 meters. Progress check. Have a go yourself, then check your answers with mine. In our first question, we have our ratio 1 is to 25, and they tell us the blueprint is 2 centimeters wide, so the 2 goes under the 1. What have we scaled up by? We multiplied by 2, so we do the same to the 25, and 25 multiplied by 2 is 50, and our final answer, 50 centimeters. Next up, our scale is 1 centimeter to 5 kilometers. We need to convert that kilometers into centimeters. To go from kilometers to meters, we multiply by 1,000. And to go from meters to centimeters, we multiply by 100. So essentially what we should see is that to go from kilometers to centimeters, we are multiplying by 100,000 because there are 5 zeros. So our ratio is the distance between the towns is 35 kilometers. We've got to multiply on a calculator 35 by 100,000 and we get, what have we scaled up by? We've multiplied by 7, and what we do on one side we do on the other side. So our 1 multiplied by the 7 on the left is 7. And our answer there is in centimeters, so our final answer is 7 centimeters. Next, let's convert that 2 centimeters into millimeters. The part measures 9 millimeters on the model, so we have our 9 underneath the 3. What have we scaled up by? We've multiplied by 3. And what we do on one side, we do on the other. 60 millimeters. And you can leave your answer in millimeters, or if you want, you could also say 6 centimeters. It doesn't matter. Both answers are acceptable. Next up, we have our 1 centimeter to 1.5 meters. Let's convert that 1.5 meters by multiplying by 100, and we get 150. We have our ratio. The wall is 4.5 meters long. We convert the 4.5 into centimeters by multiplying by 100. 4.5 times 100 is 450. What have we scaled up by? We've multiplied by 3, and we do the same on the other side. So we get 3 here. In the drawing, we would have 3 centimeter length. Next, we have a map with a scale of 1 is to 50,000. And they tell us the two cities are 8.4 centimeters apart. So we have our 8.4. What have we scaled up by? We multiplied by 8.4. And we do the same on the other side. So let's first convert 420,000 centimeters into meters. We would divide that number by 100, so we would take off 2 zeros and we'd have 4,200 meters. As you can see, we've taken off that 0 and that 0. Now to convert meters into kilometers, we divide by 1,000. So 4,200 meters equal to 4.2 kilometers. Last question. A scale model has a scale of 1 to 75. The actual building is 45 meters tall. What is the height of the model in centimeters? Let's convert that 45 meters into centimeters. So we have 45 meters multiplied by 100 and we get 4,500 centimeters. Our ratio 1 is to 75. Now we place our 4,500 under the 75. What have we scaled up by? You can check on a calculator. You can go 4,500 divided by 75 and you'd get 60. So we have scaled up by 60 and we multiply the 1 by 60 and we'll get 60. Height of the model is 60 centimeters. And that's a wrap, guys. Hey guys, this is Casey at Onetreemath. If you like the content, please remember to like and subscribe. Also, if you'd like some online tutoring, please email me at onetreemath@gmail.com. Cheers.